morning, everyone. Thank you for participating to this new seminar of the Thai Italian Chamber of Commerce. I'm admitting the participants to our virtual meeting room. Today, as you know, we have a distinguished guest from Metropolitan Electricity Authority, connected from Bangkok with us. And it's a great pleasure to have two speakers attending this event. They will display a presentation, and of course, they are also glad to share any type of information in a Q&A at the end of the presentation. And with no much further ado, I will just introduce our speaker. The first one is Mr. Jirasak Wongsawang, actually Director of the Power System Planning Division in the MEA in Bangkok. And at the moment, he will be the opener of the webinar for us. And right after Mr. Jirasak opening, the other distinguished guest is Mr. Kangwan Jarernkornburi, who is Electrical Engineer and Corporate Development Department of the Metropolitan Electricity Authority, MEA. So thank you a lot for being with us this morning in Bangkok. And I will let Mr. Jirasak to open our webinar. Thank you a lot, everyone, for being with us.
ครับสวัสดีครับ Morning, ladies and gentlemen. Welcome all the participants to today's seminar on MEA Power Distribution System Improvement Expansion Project 13 and MEA Development of Underground Power Cable System Project. My name is Jirasak Wongsawang. I am a Director of Power System Planning Division from Power System Planning Department of MEA. Metropolitan Electricity Authority, or MEA, is a state enterprise responsible for acquiring and supplying electric power to the consumer in Bangkok metropolis, Nonthaburi and Substation province, covering area of 3,192 square kilometers. MEA had a total employee about 8,000 people and divide the proportion of care into 18 areas. We have approximately 4 million customers in total. MEA had electricity consumption in the area about 52,000 gigawatt hours from 190,000 gigawatt hours of electricity consumption in Thailand, and had an average annual customer and electricity demand growth rate of approximately 2%. I invite you to watch the video introduction about MEA.
Electricity Authority, or MEA, we foresee the future and strive for being internationalization on account of we believe stable basis brings prosperous future. Reliable power distribution system, develop communication technology to invent genius network. Advance the underground cable projects on significant roads in our service areas to serve non-stop necessity of businesses, industries and communities' power consumption. MEA leverage services to international standard together with personnel development. Make the customers meet over expected satisfaction with our The Right innovation. MEA Smart Life application, all about MEA services in your hand. Non-stop to elevate and support green energy. The new MEA head office ideal building is designed and decorated to support environmental friendly and to be happy workplace. MEA aim for developing modern innovation to enhance the well-being of customers and uplift the quality of the cities in prospect future. Metro Grid Enabler, or the MET, Metro Power Network System of MEA, will draw all three significant cities be the smart metro from now on beyond tomorrow. Now it's time to turn on smart metro. Metropolitan Electricity Authority.
Okay, after everyone has watched the video introduction, I would like to bring you all to main session of today's seminar on MEA Power Distribution System Improvement and Expansion Project 13 and MEA Development of Underground Power Cable System Project. I would like to introduce my colleague, Mr. Kangwan Jarernkornburi. He is electrical engineer and he will share more information with you. If there are questions to ask, you can ask Q&A session at the end of the main session. Let's move on the main session of the seminar.
Ladies and gentlemen, we are delighted to share all of you MEA Power Distribution System Improvement and Expansion Project 13 and MEA Development of Underground Power Cable System Project. This presentation will be divided into three main parts. First of all, I will give you the introduction to MEA Power Distribution System. Then, MEA Power Distribution System Improvement and Expansion Project 13. And the last one, MEA Development of Underground Power Cable System Project. Let's start with Introduction to MEA Power Distribution System. Metropolitan Electricity Authority, or MEA, is a state-owned enterprise responsible for acquiring and supplying electrical power to the consumers in Bangkok metropolis, Nonthaburi, and Samut Prakan provinces, covering an area of 3,192 square kilometers. Thailand has adopted the Enhanced Single Buyer Model, or ESB, which authorizes EGAT to be in charge of the dominant electricity supply and the sole buyer of electricity. Electricity generation system consists of EGAT generators, IPPs, import from neighboring countries, SPPs, that supply power to EGAT transmission system, and VSPPs that directly supply to MEA or PEA distribution system. Some SPPs also directly supply to industrial users. MEA is responsible for distributing power to end users. This picture shows an overview of MEA's power distribution system. Starting from number 1, MEA receives power from EGAT. EGAT generator number 1 shown in the picture, an IPP, at a voltage of 230 or 500 kV through the transmission line to MEA Terminal station, or number 2 shown in the picture. Then, the terminal station will step down the voltage to 69 or 115 kV and transmit power to 69 and 115 kV customers, and substations showing number 3 in the picture. SPP or VSPP connecting to the grid at this voltage level can feed the power to the system. The substations will then step down the voltage and transmit power through feeder lines to 12 and 24 kV customers and distribution transformer or number 4 shown in the picture. Along the way, the grid can receive power from the solar farm, supply the power to EV stations, and charge or discharge ESS batteries. Then, distribution transformer, number 4, will step down the voltage to 230/400 volt, supplying the power to the resident customers. Some houses installing solar PV rooftop can sell the power back to MEA depending on the contract. This picture shows 230 and 500 kV transmission lines and terminal stations system. EGAT transmission lines of 230 and 500 kV will transmit power to terminal stations in the MEA area. Some terminal stations will use MEA sub-transmission lines of 230 kV to supply power to MEA's own terminal stations. This picture shows MEA terminal station and substations. EGAT high voltage station and 17 MEA terminal stations will step down voltage from 230 kV to 69 and 115 kV to transmit power to the sub-transmission lines to the 153 substations and 69 and 115 kV customers. You can see that the location and the distribution of the substations depend on the electricity demand, which is quite dense in the center of Bangkok. This picture shows MEA substation and feeder line system. Substations will step down the voltage to 12 or 24 kV and transmit the power through feeder line system. Feeder line system means network of conductors which feeds power in different localities from substation. These feeder lines will supply 12 and 24 kV customers and distribution transformers, which will step down the voltage and transmit the power to low voltage customer. This picture shows MEA Terminal Station. MEA Terminal Station is responsible for receiving electricity from EGAT to supply power to substations and customers. It consists of terminal station building and terminal station equipment with 230 kV switchgear and transformer which step down the voltage from 230 kV to 69 or 115 kV, and the last one, 69 and 115 kV switchgear. MEA substation is actually similar to terminal stations in the previous slide, but it is smaller with different voltage level and is responsible for transmitting power to feeder line. It consists of substation building and substation equipment as well, with higher switchgear and lower switchgear and the transformer in the middle. That is 69 or 115 kV switchgear. The transformer in the middle that step down the voltage from 69 or 115 kV to 12 or 24 kV and 12 or 24 kV switchgear. Substations are controlled by a SCADA system. Its control system architecture comprises computers, network data communications, and graphical user interfaces. It can monitor the fault and control switchable operation of the substation. Overhead line system is MEA's aerial power distribution system, which is commonly seen on the roads. At the top of the pole are 69 or 115 kV transmission lines, showing number 1, and 12 and 24 kV feeder line, showing number 2. Lower, number 3, is a low voltage cable transmitting the power to residential houses, and the lowest, number 4, is the communication cable or fiber optic cable for telephone and internet that belong to telecommunication companies. Next, I will show you MEA Power Distribution System Improvement and Expansion Project, the 13. We start from the objectives of the plan. The plan has 2 objectives. The first one, to serve the increasing power demand and number of customers in the future. And number 2, to improve the power system reliability. For number 1, you can see that the red line shows that the demand for electricity is higher by 1.79%, and the green line shows that the number of customers had also increased by 2% in the same direction from 2021 to 2027. For number 2, the power system reliability, or in other words, to ensure that customers will always have the light on with no interruption. The index that we use to measure this are SAIFI and SAIDI. SAIFI is a number of failure, while SAIDI is a failure duration. The lower SAIFI and SAIDI are, the better reliability is. From these 2 objectives, now comes the work content and the amount of work, which consists of 5 sub-plans. Number 1, terminal station and substation system plan for building new power station and improving existing stations. Number 2, sub-transmission line system plan for building new lines and improving existing sub-transmission lines when a new power station is formed or there is a change in the power distribution scheme. Number 3, medium and low voltage system plan. Number 4, underground cable system plan. And number 5, the last one, power distribution efficiency improvement plan. For example, installing a DMS, distribution management system, or TLM, transformer load monitoring system, that will help improve the stability of the electrical system. This picture is just for clear understanding again illustrate the scope of 5 sub-plans with explain area matching to voltage level. You can see that number 1 is a sub-plan for terminal station and substation system plan. And number 2, sub-transmission line system plan. Number 3, medium and low voltage system plan. And number 4, underground cable system plan. And the last one, number 5, power distribution efficiency improvement plan. You can see that number 3 to number 5 are applied in the same area. Let's see the smart grid roadmap in the Project 13. MEA adopted smart grid technology throughout the grid. Smart grid in MEA system can be divided into 3 main parts: high voltage, medium voltage, and low voltage smart grid. Part 1, high voltage smart grid, which already exists in MEA system, is divided into SCADA and substation automation in the transmission and automation system. For medium voltage and low voltage smart grid plan, I will tell you in chronological order as follows. AMI for commercial, industrial, or C&I customer, RE EV station that will be installed from 2022 to support increasing RE and EV. AMI and OLTC or on-load tap changer transformer that will be installed to support solar rooftop from 2022. A full DMS or distribution management system that will be installed in 2024 to reduce the duration of feeder outage within 15 minutes. ES or microgrid pilot project that will be run in 2024 to 2027 for future system and cost reduction. A full transformer load monitoring or TLM project that will be installed in 2027 to monitor load and loss in the system. And this is the overview of smart grid roadmap that's going to happen in the MEA area. The investment cost of the project consists of 2 portions. 1, foreign currency portion, and 2, local currency portion. Foreign currency portion is for foreign materials, and local currency portion is for tax for imported equipment, construction and installation cost, and overhead charge. The investment cost of each sub-plan is shown in the table. That makes total investment cost of the project about nearly 100,000 million baht. From the investments mentioned earlier, the economic analysis shows EIRR of the project 12.65% and FIRR is 10.89%. And that's all for MEA Power Distribution System Improvement and Expansion Project 13. Now, let's move to the last part of the presentation, the development of underground power cable system project. The left-hand side is the overhead system. You can see the lines on the pole. At present, MEA planned to change overhead system to underground system. The obvious physical evidence is, of course, there are no lines and poles along the road anymore. The lines will be installed underground instead, but still perform the same functions as before, with some additional equipment. From the picture, it can be seen that the green underground transmission line along the road will supply power to high voltage customers and substation. Then, substation steps down the voltage and supply the power to middle voltage customer through link main unit or RMU. Distribution transformer, which is once installed on the pole, is now changed to the unit substation on the pathway. The unit substation will step down the voltage and supply the power to customer houses. As the important reason of power outages in MEA responsible area are from animals or tree touching live part of the system. So, the underground cable system will make the power system more reliable. There are two criteria for selecting the area for the underground cable project. Number one, areas along electric trends or other utilities that demand for electricity tend to be increasing and have limitations in expanding the aerial cable system, both physically and system capacity. Number two, the area that is ready for construction. Main duct bank is already constructed along with other electric trend or utilities projects. MEA service area is supplied power by the underground cable system covering 48.6 km within the following areas: สีลม ปทุมวัน จิตรลดา พหลโยธิน พญาไท สุขุมวิท and Nonsi areas. There are additional 187.5 kilometers of the projects currently in progress, covering the following: additional Lama 3, Nonsi, Ratchadapiseck Asok, Ratchadapiseck Rama 9, the capital of AEC project, and the Quick Win project. Underground power cable system of Project 13 covers 77.3 kilometers in the MEA service area, having an investment amount of almost 15,000 million baht, and the whole MEA underground power cable system project has an investment amount of almost 88,000 million baht. This picture shows the example of landscape before and after the project, changing the overhead system to the underground cable system in the MEA service area. These pictures also show the completed projects mentioned earlier along 4 main roads of Bangkok: สีลม ปทุมวัน จิตรลดา and พหลโยธิน. This pictures also shows additional completed projects on Rajdhevee Road, Sri Ayutthaya Road, Yoti Road, and Petchburi Road. This completed project can help create a beautiful landscape of Bangkok and safe and comfortable living for the people of the metropolis. Besides supplying electricity to the customer, MEA also do some other related businesses. You can find more information on the website shown in the slide.
Okay, thank you very much. I believe this was the last slide. Yes, and so thank you a lot for delivering this video presentation. And in the chat, we have few questions popping up. And the first one is about ES microgrid. Can you share more information about ES microgrid? Is it a new technology?
Okay, thank you for the question. About the ESS microgrid, can I share the slide? Can I share the screen?
Yes, we should be able to share.
Do you see this website?
Yes.
Sorry that everything in this slide is in Thai. Actually, the ESS stands for the energy storage system. It's come from many technology, for example, hydro, compressed air, five wheels, stationary batteries, mobile batteries, what probably be stationary battery or the mobile battery that gonna happen in the future when EV increase the number. Is this a new technology? Yes, I mean, say because MEA is not the organization that can develop this technology itself. Be open for these kinds of technology, but the price is still very high. So we're not included in the plan now, but we have the pilot project in some area, for example. And what about the microgrid? Microgrid is based on the concept of DG or distributed generation. We try to separate or we try to distribute the power generator or power generation according to its load. For example, this load have a big amount of load, so the supply should be the nearest as possible. So it's come this kind of the technology. Then another reason is that for the climate change, we try to focus on renewable energy. So it's come the word microgrid that we can hear these days. Microgrid is when some community help together or collaboration on the energy. So some we have solar, some we have wind, some we have energy system. So they try to manage the energy within the small village or small grid. So is now today according to this slide, you can see that until now, MEA or electricity power structure in Thailand is like enhanced single buyer, so for the top down, right, from EGAT to MEA or MEA according to the service area. But in the next decades, I guess it will be like smaller grid that each community can manage itself. That is the first question. So if you are interested in these things, you can visit Smart Grid Thailand for more information. So I will stop share first. I've sent a link in the chat. Okay.
Thank you.
So that is the first question.
Yes, thank you for the explanation. and probably this is going to also reply to the next question, because the next one was, are there new technology available for the Metropolitan Electricity Authority in order to benefit of a more efficient power storage? This type of question comes from the fact that for the Italian Chamber of Commerce, we've been working in ASEAN Sustainable Energy Week, and we saw that some company are promoting a new way and more efficient way of storing energy. Is it something that also your R&D is browsing in order to have, let's say, batteries more efficient for the next future or for the present?
I think that we aim to how to manage everything more efficient, as you say, and one of the equipment is of course power storage. But I'm not sure that we will focus on the technology itself and develop itself, but we open for new technology that can adopt in our power system. For example, now we have like pilot project. Let me see. We have some pilot project that use the energy storage and see what's going to happen when we adopt these kinds of technology to our system, and try to collect the data and try to manipulate the data that is fit or not, because sometimes it's not when the demand occur, for example, and it's not much big enough. Sometimes it's not worth for investing, you know. So for the answer of this question is yes, we open for the technology, but probably we will not do the R&D itself, but we open for the collaboration.
That's also very interesting. And about another question is mostly related. We were thinking, let's say, from basically more Italian or European point of view. In Europe, we do not experience like mega cities like in Asia. When we see about Thailand, for example, we see Bangkok is extremely populated, probably over 10 million people. And we believe that the energy demand is stressing a lot MEA and other supplier of energy. And in other part of the city, for example, in other part of the country, you have low population, so maybe it can be comparable to other small cities in Europe. And about this situation, and thinking also about the future of fast train infrastructure, do you think like a new alternative energy sources will help to have less stress in the demand of energy in the city of Bangkok? Or what is your vision in this?
Okay, thank you. Very interested and very hard question to answer. First of all, we cannot deny that the trend of the trend of saving the world is the most important thing today. And Thailand follows some big country, like one country is Italy as well, from America, from Europe, from Japan, from Australia, to follow which way of managing energy should be and should going to happen in Thailand, especially in the metropolitan area. So in our area, comprising 3 provinces, we don't have big land for investment of solar farm. So the kind of solar should be solar panel or PV, photovoltaic solar panel, for example. The question is it really help with and without energy storage? Because the energy storage price is still very high. So when we use this kind of technology, so the answer can be yes and no. Yes, about what? Yet about the people who use or consume the energy much during the day when the sun lights when the sun shines, and it's produced the electricity. So it is consumed at that time without the energy storage. And this is the current step that MEA facing. And know for the group of people or the households that don't use electricity much during the day. For example, we are in the office, we don't use electricity at home, but our house installed solar PV on the rooftop, for example. So this kind of people will generate, or this kind of house install PV panel will generate electricity back to the system. So the key points now is the energy storage. If we have the appropriate energy storage, appropriate for the technology, appropriate for the price, we can manage the excess or this amount of power and use for make it more efficient. That is my opinion. But comparing to PEA, they are responsible for other provinces except for these three provinces. You can see that MEA has a big land for installing solar farm, for example. Or wind, but in MEA we don't have strong wind to produce wind generator, for example. We have only one project in Bangkok district to see. So most of the thing that we use for save the energy, the world is let's say solar PV at the moment.
I understand, and thank you for sharing, Mr. Kangwan. And in the meantime, I would like to also ask our participant if anyone would like to add in the chat an inquiry. This is a good timing for do so. In the meantime, while we're waiting, I was thinking this one is maybe more related to research and development. We've been listening sometimes talking about superconductors. Superconductors is something that is applicable at the daily work for the energy saving or energy efficiency, or is still something that is still in the lab and it is very difficult to bring to our daily life?
What kind of superconductor you mentioned? You mean for the transmission line system, or?
Yes, for example, yes, like something that we can actually apply, for example, in a power grid, if applicable to a power grid in a city.
Okay.
In a more.
If you can remember, in the according to this slide, in the planning of the 13th plan, we have sub 5 plans. The last one is about energy efficiency, and superconductor is one of interesting topic. But however, we are controlled by the government. So any other courses that we install, that we use for investment, have to be just again by the government. But we try to lower the losses in the grid. For example, we use the low loss transformer. That of course is the price is higher than the normal transformer. But for the total system, the benefit it is give the more benefit when using it, for example. So actually we try to use some, some company come to our MEA and talk about their products that we can use for improving our grid. And actually we welcome any other technology as well.
Thank you for sharing. Maybe last question, because we are reaching 1 hour of your time. we saw recently also from recent trade show, like in ASEAN Sustainable Energy Week, there is a lot of emphasis about electric vehicles, EV. Sometimes we can even see in our neighborhood some private home with a plug for their vehicle, or we saw also some hotel in Bangkok with the shuttle fully electrical. We understand that also this is a challenge for the power grid in the upcoming years, probably. What MEA is doing in order to be ready eventually to assist the demand of upcoming electric vehicles in the near future?
Okay. I can divide my answer into parts. The first one is, as we are utilities as supplying power, we have to say that we are ready for supplying this kind of demand from electricity in metropolis area. Another part is related business. For example, as the charging station provider, we are interested in this area as well, and have the cooperation with other organizations to do this kind of business to make it convenient for the people in the metropolis area. So we try to, for the energy charger itself, we do R&D for this as well, to see that which kind of technology gonna suit our situation or our area. We try to calculate. Nowadays we have, as I remember, 3 pilot stations in our area, to see that what gonna happen. One is in Chitlom, one is in Bang Khun Non, and another one is in Samut Prakan or Lasan area. That we give, I think nowadays is free of charge, to see that what happened, what the traffic, what we should do in the term of technical adjustment.
Thank you.
So,
thank you very much.
Yeah. So my conclusion is that for at this energy supply, we are super ready for that. And for the related business, we still looking for the cooperation and the opportunity to go in this, because it's the only one. If you compare the solar PV and the EV will increase our the consumption and the energy consumption in our area. While the solar will, frankly speaking, will decrease this consumption.
Thank you very much. Also, thank you for the hints. And of course, as I mentioned, we are recording the webinar and we will upload it online on our YouTube channel. So hopefully also after this presentation, we support MEA by bringing some partner for developing new projects in the future.
Hopefully, yeah. Very welcome. I appreciate it.
Okay.
I think for today that's all, and I would like to thank very much the Director of the Power System Planning Division, Mr. Jirasak, Wongsawang, to make this webinar possible. We really appreciate your time. And also we want to thank the engineer, Mr. Kangwan, Jarernkornburi. Sorry for my pronunciation.
Good pronunciation.
Okay. If everyone has no question, then we will proceed with the closing remark of seminar. Or if you have any question, you can scan QR code or to fill your question. We will answer your question later seminar. Finally, I would like to thank the participants as well as all related parties who participate in making this seminar have a good session. So I would like to close the seminar on MEA Power Distribution System Improvement Expansion Project 13 and MEA Development of Underground Power Cable System Project. Thank you very much. Thank you.
Thank you very much.
Thank you.